Imagine you're sinking. The more you squirm, the harder it is to escape, and the farther you begin to go down, farther and farther into the abyss of the unknown. You're not sinking in a liquid, nor a solid, nor a gas, but a non-Newtonian fluid. Only by strength and patience will you escape. My name is Tabitha, and I express an interest in the sciences, and am therefore informing you on the phenomena of quicksand. Through extensive research of online articles and short informational documentaries, I have obtained enough information to inform you on the topic of quicksand. I'm informing you in the following categories: non-Newtonian fluid, areas in which quicksand is naturally found, how it forms, and how it differs in reality from the depictions in movies. First, I'll discuss non-Newtonian fluids, but in order to know what a non-Newtonian fluid is, you must know what a Newtonian fluid is. A Newtonian fluid can get technical, but according to Chemical Engineering Learning Resource, it is all gases and water and alcohol. They're Newtonian because they follow Newton's law of viscosity, and these fluids behave like we expect olive to form, like water in a glass or oil in a measuring cup. On the other hand, a non-Newtonian fluid behaves more like a solid or a liquid, but is all dependent on strain and stress. Stress is pressure, while strain is what occurs afterwards. So if you were to kick a cardboard box, that would be the stress, while the dent that you made afterwards would be the strain. Viscosity, in simple terms, is defined as the flow of a fluid. Thick, slow-flowing fluids like syrup have high viscosity, while thin, fast fluids have low viscosity like juice. Quicksand will be described as a decrease in viscosity with stress, and as one where the fluid becomes more liquid-like the more pressure that's applied. Now let's discuss where quicksand is found geographically. Quicksand can be found in areas of natural flowing water like beaches, swamps, and riverbanks. It's possible anywhere, but according to life science author Matt Stoniak's research, they are mainly popular in the coast of Southeast America, Utah, Arizona, and New Mexico canyons. As stated by expert Darrell G. F. Long, quicksand is due to upward shifting flow and movement of water from the source, and is more likely to occur closer to the shore. Quicksand is also found in deserts, but it's highly unlikely. Because of the lack of water, air will accompany the sand instead, and the downsides of sand dunes have the biggest probability of having quicksand. They are only centimeters tall because there's no balance. Now that we learned where quicksand is found, let's review how quicksand is formed. Quicksand is formed by the sand grains and the flow of water. From the top, it looks like a solid, and during formation, the sand grains form mass with a space in between, and according to Darrell G. F. Long, takes the form of a house of cards balanced on each other. Water is the other ingredient, and as reported by Matt Stoniak, author for Mental Floss, without water, it would be dry quicksand and a bottomless pit. At this point, it's easy to be fully immersed, and in the natural, it's not practical, and has only been created in labs, and the scientists say it can still be a possibility near the sand dunes. At this point, water is added and fills the gaps in between the sand, and the running water makes the sand interact with silt and sediment, creating a casting material. When a dramatic change in pressure occurs, the quicksand liquefies, causing the mass to sink in a quick fashion. The more movement, the faster the liquefaction. Now that you know how quicksand is formed, many of you may already have your own visual as to what it looks like to be in quicksand from movies, but let's look at how it differs in reality. According to Nicholas Baclar with National Geographic, it's impossible to drown without voluntary movement in quicksand. Humans have a density of 1 gram per milliliter, while quicksand has a density of 2 grams per milliliter, so you can only go waist deep without struggling. Also, you can escape, but not by any human strength. Water is what loosens the sand grains from the force, but the force needed to pull one out would be the same required to pull a medium-sized car. To actually escape is close to impossible, but according to Dr. Vaughn at the University of Amsterdam, you must wriggle your legs around to create space between the legs to loosen the sand. This will work if done slowly and progressively. In conclusion, my purpose was to inform you on the phenomena of quicksand with support through the topic of natural sciences. Based off the generalities of the information, I have further informed you on non-Newtonian fluid, where quicksand is found naturally, how it forms, and how it differs in reality than in movies. If you encounter quicksand, know to stay still, get the water to flow, and enjoy the view until professional help arrives. Thank you, and do you have any questions?